Wind. You might be asking, what is a wind? Wind is a natural force produced by air. But you might be asking, how come a little thing could affect in our lives and in our society so much? How does it work? And another boggling question of it is, how did it help improve our society? How did it help our technology? Our scientific technology, rather. Come with us. In this video, we'll be tackling how did it work, how did it help us, and how will we improve it. Now, it might be boring for a little while, but I assure you, you will enjoy the rest of the journey.
Air pressure. Air pressure is the force exerted by air on a surface. It plays a crucial role in our atmosphere, affecting everything from weather patterns to human breathing at high altitudes. As you go higher in altitude, air pressure decreases because there's less atmosphere above you. That's why mountaineers use oxygen tanks when climbing high peaks. Air pressure is measured in units like kilopascal, millibars, and inches of mercury. Meteorologists use these measurements to track weather changes and wind patterns.
Why does the wind blow? It all starts with pressure. Air moves from high to low pressure, creating wind. When pressure differences are strong, storm-like typhoons form. Even pilots adjust flight paths based on pressure change. Let's explore how horizontal pressure variations shape our weather.
Wow. So, you might be asking, how is that so accurate? How do scientists and meteorologists accurately measures them? Well, just like our fever, our temperature, atmospheric pressure also have measuring tools. One of this would be the barometer. Now, barometer measures pressure. This is made of mercury and aneroid types. And the second type would be the barograph. It records pressure changes over time. And lastly, the scientific technology is the digital sensors. It provides real-time pressure readings, and that is what we see in our news, such as broadcast about upcoming typhoons, and you name it. Now, why does this matters? Because this helps meteorologists predict approaching storms. And when we know that there are storms approaching, we can at least prepare on what is coming and how strong this storm is.
Did you know the Earth's rotation bends the wind? This is the Coriolis effect. In the northern hemisphere, winds curve to the right, while in the southern hemisphere, they curve to the left. These shifting winds drive trade winds and monsoons, shaping agriculture and weather patterns worldwide. Let's dive in.
To track and predict weather, meteorologists use two types of maps: surface charts and upper level charts. Surface weather maps show high and low pressure systems, weather fronts, and precipitation areas. These are the maps you often see on the news. Upper level charts, on the other hand, show jet streams, fast moving air currents in the upper atmosphere that steer storms and influence global weather patterns. For example, meteorologists track hurricanes by analyzing both surface and upper level maps to predict their path and intensity.
Newton's law explains how wind moves. The first is inertia. Newton's first law says an object in motion stays in motion unless acted by another force. That's why wind keeps blowing until friction or obstacles slow it down. The next is Newton's second law. It states that the force equals mass times acceleration. In weather, stronger pressure difference creates stronger winds. That's why when pressure drops quickly, storms intensify, leading to powerful typhoons. Newton's law are in action all around us.
Ayan, okay na yun. Tatlo lang yun.
Okay na to?
Tatlo lang naman to. Kailan tulo? Wala pa. 7 minutes pa.
Ay, transition. Taro magtungod.
Ah!
Usap!
Okay. Off na nga.
Not all winds behave the same way. At high altitudes, we have geostrophic winds, which flow parallel to isobars due to the balance between the pressure gradient force and the Coriolis effect. Gradient winds, on the other hand, curve around high and low pressure systems. Closer to the ground, surface winds are slower because of friction and terrain. Unlike high altitude winds, they don't flow parallel to isobars but instead cross them at an angle. A great example of wind influence is jet streams, which can speed up or slow down air travel, affecting flight times. Air doesn't just move horizontally, it moves vertically too, and that's what fuels storms. When air rises, it expands and cools. This leads to cloud formation and precipitation, which is the driving force behind storms. On the other hand, sinking air compresses and warms, creating clear, dry conditions. For example, hurricanes form when warm ocean air rises, cools and condenses into storm clouds. This process releases heat, fueling the storm's intensity. Understanding vertical air motions is key to predicting severe weather and keeping people safe.
Seriously. Okay, I'm so sorry to interrupt. I think Vince is done. He's flown away. So, all of our discussions on these topics, or in this topic, has real world impacts. And about air pressure and wind content, in general, examples would be weather forecasting. So, high pressure equals clear sky, low pressure equals storms. And that is just the basic and general knowledge when we talk about air pressure and wind contents. Another thing would be that a general application in our world would be that pilots use jet streams for faster flights. Now, it may seem that we are on an advanced level of our technology today, but still we rely on nature, and that would be we also rely on wind, and not just us, but also pilots. This saves lives, this saves fuels, and this saves a lot of time to travel. And another would be climate effects. Monsoons and trade winds impact rainfall and agriculture. Now, through this, and by all means, it just not only helps our technology but also puts food in our table by nurturing every agricultural farm out there. Now that you have done watching the video, I want you to take note of these 3 most important things that you should note in our video. Number 1 would be wind is driven by pressure differences and Earth's rotation. You have to take note on that, guys. That is the number 1 thing you should note. Again, wind is driven by pressure differences and Earth's rotation. Second would be weather maps help predict storms and climate patterns. You should always take note of that, guys, because that is one of the most essential thing that why we're discussing this lesson. And lastly would be understanding winds improve weather forecasting and disaster preparedness. I've said it once and I've said it again. These studies help and save lives when it comes to incoming storms and incoming weather patterns. Especially Philippines is let's just say it's been visited by a lot of typhoons and storms throughout history. So, once again, my name is Jai Kasipli.
Vince de la Salde.
And my name is Katubig John Ricks.
Tinatalo. 1, 2, 3, go.
And we are the Group 8.
Tanong.
Pati
halaang buksan ang isipan. Sa science o agham, tayo na sa siniskwela. Tuklasin natin ang siyensya, buksan ang pag-iisip. Tayo'y likas na scientist. Tayo na sa siniskwela, tuklasin natin ang siyensya. Kinabukasan ng ating bayan, siguradong makakamtan.
Sa daigdig ng agham, tuklasin ang kaalaman.